That's great. So my name is Balazs, Bucsay, and I'm going to present you this topic. And probably it will have no press coverage in the future because it's technical and no journalist will understand what I'm talking about. Okay, so a little bit about me. I'm a Hungarian hacker. I have 4 strictly technical certificates listed on the slide. I'm currently unemployed by choice. I'm doing research, resting, and lots of other stuff at the moment. I started to do IT security in 2000 with Ringo debuggers and disassemblers. And I had one major project in 2009. I had a presentation about it on this conference, so maybe you remember. The project was called G.I. John, and I had several presentations around the globe in US, UK, Russia, and Norway, and of course here in Budapest. You can find my webpage on the bottom of the slide, my Twitter account, so if you liked my presentation, please follow me on Twitter. And there is my LinkedIn profile as well. It's not working really well, so I won't use it. So a little bit history about chroot. First, it was implemented in version 7 Unix in 1979. Then later, it got inherited into BSD. And in 2000, the FreeBSD implemented a hardened version of this chroot. It is called Jail. In the same year, the Virtuoso, or previously called OpenVZ, implemented the containers, the Virtuoso containers. And after a while, in 5 years later, the Solaris implemented something similar. It was called chroot on steroids, but it's basically the Solaris containers. And a little bit later, in 2008, there was something called Linux containers introduced in the Linux kernel. It is part of the kernel right now. So what's chroot? Chroot is a privileged system call. With this system call, you can change the process. So all processes in the operating system has a process structure in the memory. That process structure stores different kind of entries, different kind of process properties. For example, the current working directory vnode and the root vnode. You can change easily the current working directory vnode just using the cd command or the chdir system call, and you can change a little bit more. So it's a little bit more harder to change the root vnode of the process because you have to call the chroot system call in the kernel, and that's a privileged system call, so only root can call it. And the reason why it's privileged and requires root, because if any unprivileged user could call it, that would make it really easy to escalate your privileges. So it's pretty easy to create a privilege escalation exploit if the system call is unprivileged. So why do we need this? It's a pretty lead stuff if you want to enclose your process into a directory. So you just call this system call, and the process will think there is nothing beyond the root directory anymore. What is it used for? It is mainly used for testing environments, dependency control, compatibility recovery, and privilege separation. For example, the recovery phase, what I can tell you about, if you have a crashed Linux machine, you cannot boot it anymore. You just grab a live CD, boot it in. Then you have a working kernel from the live CD, and you can mount the root partition with the live CD and chroot into the root partition of the crashed PC. That way you will have a working kernel from the live CD and a not really working file system for the root partition for the crashed PC. And that way you can use a working Linux to recover your your cache PC and then make it work again. That's the basic use of the chroot if we are talking about recovery. And it is used for privilege separation, which is sometimes not a really good idea, but you can decide after my presentation if you want to use it or not. So before I start the stuff that matters, I would like to ask you the question that, what do you think? Is it a security feature, the chroot? Show your hands if you think so, please. Okay. 2. I have to say, no, I'm sorry. This is not a security feature. Back in time, it was. But since that, they just realized it shouldn't be used as a security feature. So, so you shouldn't use it like it is as it's one. After the presentation you would like to create a chroot, still want to create a chroot, then please read these 2 slides after my presentation again, because that way you can make a more secure, let's say, but more reasonable chroot. First of all, you have to make sure that all of the directories are owned by the root user and root group. Then you have to make sure that no super user process is running in the chroot. And if you are using, and you will use users in the chroot, you have to make sure that the user IDs and the group IDs are distinct and unique IDs, so you shouldn't mix up with the original system. And you have to make sure also that no sensitive files can be created in directories or modified. And if you are coding an application that will be chroot or will use the chroot system call, then you have to make sure that you close all the file descriptors before calling that system call, and you use the chdir. You change the current working directory of the process before changing the root of the process, because if you forget these points, it is more easy to break out from the chroot. And last but not least, you shouldn't mount the procfs at all, because it's really dangerous, let's say, for the security of the chroot environment. And if you want to use an empty file system or empty directory for the chroot environment, just use the var empty directory, because that's the reason why it's there. So when you have to deal with chroot, you have basically 2 scenarios. One when you have a shell access, and the other one when you only have file system access. When you have shell access, for example, you got an SSH account, and you can just SSH into the server, and you will get a chrooted environment. That way you cannot leave your directory. You're just enclosed in that directory structure. Other scenario could be regarding the shell access, when you have a chrooted Apache, and you have somehow a way to execute scripts on the server in that environment, PHP scripts or pair script or whatever. And the third one, for example, is you have a vulnerable application that you have an exploit for, and that application is chrooted, and you can execute any kind of machine code in the context of that vulnerable application. Then that's another scenario. And if we are talking about file system access, then we can think about chrooted FTP and SCP services. For example, most probably you have a web page, or you saw a web page previously, and that was hosted in a virtual hosting company server on a shared hosting server. And those companies most of the time use chrooted FTP servers. So you got an account to your web page. You can use that FTP, and you will be logged in your directory. You cannot leave. You cannot access the etc, the bin, or any other directory. It's just your home, right? So you can upload your files there, but you cannot leave that. I'm going to present you 8 or 7 techniques how to break out the chroot. most of the techniques, not all of them, based on the same scenario, that somehow you get root, you have root access to the environment, then somehow you have to get a file descriptor outside of the directory. And when you find that, when you have that, you can just leave the chroot environment. I'm going to show you how. And find the original root, call the chroot system call again. That way you will be in the original root again, and that way you are escaped. I have to mention that this is working really well on most of the Unices, for example, Linux. But on FreeBSD and, for example, FreeBSD, it's not really working that well because FreeBSD stores the root vnodes and other kind of stuff in a linked list. So it's not just a process structure where you have one entry and you can overwrite it. It has a linked list. So if you change a root, the linked list will be added with one more entry, and that entry will have the last chroot, the new root. And if you break out, then you will have the last just before the last root, so you cannot leave that. So it's a little bit tricky on FreeBSD. So let's see how it works. This is the full file system. You have the root here. On the top, you have all necessary directories just under below. In the home, you have the chroot directory. You have all of the necessary directories in the chroot. In the home, you have the chroot too, so you know the way. When you call the chroot system call on the chroot directory, that will be the root of the process. So it won't be able to see anything else above that directory. So the process will think that's the root, and there is no way to leave. That should be it. And if you call the chroot again, the system call, then your process will be logged in the other structure, so it won't be able to see the remaining parts. If you manage somehow to break out from this chroot environment on Linux, you will see the full process, full file system. If you do the same on FreeBSD, for example, because it's using a linked list, it will be able to see just this chroot environment. This is a technique what I'm not going to tell you about. It's basically kernel exploitation or inserting a malicious kernel module. When you do that, you have root, you have access to the kernel space. You can modify anything in the kernel space. You can modify the process structure as well. And if you do that, you can just override the process structure with the vnode that you are looking for, and you are outside. But it's a really other topic, kernel exploitation, so I'm not going to tell you anything more about this. The 0S, let's say, 0S technique is the misconfiguration, as always. For example, if you have a chroot environment and the etc password file is modifiable for any user, writable for any user, then you can edit it. You can just replace your UID, user ID in the password file, and if you log in again, you will be root because you just replaced your user ID with 0. Or if you have a hard-linked chroot binary and you have the lib, for example, the bin su, and you have the bin or user bin directory writable for any user, you can just replace or place a shared library that is having that has your code, and the binary which has a chroot bit on it will execute your code in a privileged context, of course. So that's two ways how you can get root in the chroot directory. Sometimes it's really hard to find these flows and exploit those, but if you have some options, then just go there and look for these flows. Okay, the first technique is really old and trivial. If you Google chroot escape, chroot bypass, or anything else, that's the thing what you will find. If you want to talk about this topic with anybody else who knows what chroot and chroot bypass, they will talk about this flow. I sent a letter about my presentation and techniques to the Linux kernel list, and they came back with this technique that they told me that they know this technique, and they didn't care about my technique, which is different. So I said, okay, you know the way, so I won't argue with you. So let me show you. This is the full file system. We have the process which is already chrooted in here. This is the original root, but it's not accessible, and these gray directories that are not accessible from the process. This is the only directory which is, no, this is the root directory of the process, and everything below is accessible for the process, of course. And we want to break out. This is the basic scenario, right? So what we are doing is we change the current working directory, for example, just cd home. So this will be our current working directory. And after that, we call the chroot command on the user's tree directory. That will be our new root. So that way, we shouldn't be able to access anything outside, right? That's the situation. But what's really happening here, because our current working directory is outside of our root, that way we will be able to access everything, because we are already outside, right? So that's the basic, the classic technique, what is known for a really long time, at least for 10, 15 years, I don't know. The second technique is based on the first technique. It's almost the same. But here, we are not using the current working directory. As you can see, I already inside the user's tree, and I'm going to call the chroot system call on this directory, so we won't be able to access anything outside. But before I do that, I just open the home directory and save the file descriptor that is pointing on this directory. And after I call the chroot system call again on that directory, we will have a saved file descriptor outside again, so that way we will be able to see all of the directories again. It's basically the same, but there is a difference between the techniques. Unix domain sockets. This is the third technique. It's really nice. Okay. I don't know what did I do. So Unix domain sockets. I don't know if you are familiar with this. It's like internet or network sockets, but you don't have to have any, you don't need any network interface on your Unix box, because it's working without network access. If you want to do this socket, you have to bind and listen on this socket. It will create a file on the file system, and from the other process you can just connect to that file, and that way you can you can communicate between the two processes. And the best thing about this, that you can pass through different structures as well, for example, file descriptors. And it's another way to escape the chroot. So on Linux, we have an even better version of the Unix domain sockets. It is called abstract Unix domain socket. It doesn't create any files, it just works. So it does not even require file system access. So this is the file system, what we have. Our process is chrooted in that directory. We can execute any processes, any binaries in that chrooted environment, and we want to break out. So what we are doing is we start our process that will fork and create a child process that will be chrooted in that directory. That time we will have two different processes. One is the root, one is the parent, and the other one is the child. So what we are doing is we are going back to the parent process, and we open the bin directory. We save the file descriptor. We set up a Unix domain socket in the parent, and we connect to that Unix domain socket from the child. And that way we can communicate between the two processes, and we can pass through the bin directory's file descriptor, and that way the child will be outside of the root again, and that way it will be able to access the full file system. The fourth technique is the mount. This is the maybe the most trivial. We just look for the root partition of the Unix box, or because it's working only Linux, so I can say Linux. We are looking for the root partition of the Linux box, mount it into a directory, change the directory to that mount point, and chroot into that. So we will get the full root file system that we wanted. And this technical, like I said, it's working only on Linux, because Linux is not restrictive on mounting. You can mount a partition or anything else 7 times if you like. Fifth technique is procfs. You can mount the procfs, and in the procfs, you have all the information about processes. If you go into the proc on your Linux system, then you will find lots of numbers there. Those are the PIDs of the processes. In that directory, you will find different entries, for example, the root. Do you know which process has the PID 1? Maybe? Nobody? I don't think so. Somebody should know it. So this is the init process, which helps you boot your OS. And this is the init has always the first, the PID 1, and that has always the right root. So you just chroot into that directory, and you will be outside of the chrooted environment. This is the sixth technique. Move out of chroot. This was the technique what I found around 5 years ago, but I didn't do anything with it. And last year I realized maybe I should do a presentation or some research on it. So that's why I am here. It's really similar with other techniques, but it has really another really good behavior that you can use it on file system access as well. I'm going to show you that as well. So this is the file system. We are chrooted in the directory again, and the parent forks the process again. Our child is chrooted in that directory. Then it changes the child, changes the current working directory to the user7 directory. And what the parent will do is just move out the directory outside of the root. That way it will be able to see the whole file system again. The seventh technique is ptrace. This is the best, I guess. It's really cool. This is another system call. With this system call, which is an unprivileged system call, you can attach to any process on the server, on the system, and do lots of things. For example, just replace the running code with your code. So in that way, you can execute your shell code in the context of other processes. Of course, with chroot, you can attach to any process on the system. And if you have an unprivileged user, you can only attach to those processes that has your effective UID only. On Ubuntu, only root can attach to other processes, no unprivileged user. So before I'm doing the demo, I have a drink here with me. Maybe you know the name. It is called Kali. This is a gift for you if you can answer this question. Before I ask the question, but you already see that, so you can just think about this. This is an Estonian soft drink, non-alcoholic, so you can drink just after the presentation if you like. And this is a Soviet drink, so maybe you know it. It's called Chw00t. So the question would be, tell me a service that is usually chrooted. If you, okay? Sorry? I don't hear you. Vine. Bind, okay, you got it. So you can have it after the presentation, please come to me. So the live demo, the projector is not really good, so I hope you will see this. It won't be easy to read, but you will manage it, I guess. Okay, I need a... It's always changing IPs. Okay, perfect. So I have my test environment just here. As you can see, I have all the necessary directories in the directory. For example, bin, dev, etc. And right now, I can list the root. But if I call the GNU tool chroot on that directory, then I won't be able to see the root, just the new root here. And I have my tool what I created for this presentation. It is called Chw00t, that has all the presented techniques implemented. And I'm going to show you the classic technique. For that, I have to specify the directory what I want to use. I will use A, and if I push enter, I got back a shell here. And if I list the root again, and as you can see, I can access everything basically because I'm escaped the chroot. I left that shell, I exited the shell, so I'm back to the chroot environment, and I'm going to show you another technique. For example, let's see the Unix domain sockets, which is the second technique in the usage, and I have to specify another directory. Let's say it's B. We have to wait a little bit. It's doing the Unix domain socket connection and that kind of stuff, and spawn a shell. And as you can see, I'm outside again. So that was the Linux part of my presentation. I have an OpenBSD as well. I go to the chroot directory, chroot. As you can see, that's the content of the directory. If I list the root as well, it will be the same because I changed the root. I'm going to, my ID is 0, so I'm root. What I'm going to do is I just use this tool, lower my UID, I'm 80, and my GID is 80 as well. So in the other window, I'm going to go to the directory, lower my UID, so I won't be root again, and use the sleep tool what I wrote. It's a basic program. I use it for a cheat because I just want to demonstrate how it works for you. And this tool does nothing, just writing out the PID in every second and sleep for 1 second. So we know the process ID here. And I'm going to use my Chw00t tool again. I specify the 7th technique, which is ptrace for 64 bits processes. And I have to specify the PID, and I give a port 1, 2, 3, 4, and push enter. As you can see, I'm connected. What happened here? This process stopped because I attached to the process which is outside of the chroot environment, replaced the code with my shellcode. It's a bind shellcode. I wrote it. When I made this presentation for Moscow, for the PhD days, then I realized there is no usable AMD 64-bit BSD shellcode in the Metasploit, so I wrote one, and I pushed it into the Metasploit, so it is part now. I have a few modules in the Metasploit, by the way. And as you can see, it worked. I connected to that shell. So as you can see, I have my UID, my GID, which is 80, and I can access the root. So that's about that demo right now. And back to the presentation. Here are the results in this figure. It's really bad. I mean the quality of it. Which is green, that's the good or the bad. You can decide. Where you can see green, that's the working technique. First, you can see the Debian and Kali Linuxes. In the second, Ubuntu, and like I told you, the ptrace is working only if you are root. Yeah, and I forgot to show you the last other demo. I have lots of demos here. Okay, I have a Dragonfly BSD as well. As you can see, it's 4.05 release version. I go to the chroot directory, and I call my tool with the 5th technique, specify the directory, other directory, and the temp directory, and wait a bit. And we can wait, and we got suspicious because nothing happened. And if you check the console of the Dragonfly BSD, you can see it panicked. So there is a kernel panic here. If you trigger this tool, then you can trigger a kernel panic in the Dragonfly BSD, which is already fixed because I told them. And I tried to use this flow to make a kernel exploit, but it's pretty hard. It's a null pointer dereference. You can find the trigger file on my GitHub. It's pretty lit, but I cannot do anything with it. So maybe you can do something with it. So back to the presentation. So on Dragonfly BSD, the classic, the Unix domain sockets, and the move out of chroot results in denial of service. The ptrace is working properly on FreeBSD and on OpenBSD, which was a big surprise for me. The move out of chroot is working on OpenBSD as well, which is other big surprise. And on Solaris and Mac OS X, most of the techniques are working. This is the comparison between FreeBSD, jail, and on the right side, and chroot in the left side. The difference only is the ptrace. The ptrace cannot attach to other processes outside of the jail. Okay, so we had two scenarios, distinct scenarios between when we will talk. Yeah, but they told me I can go until the end because it wasn't my fault. So thank you. So we had two distinct scenarios. When we had the shell access, and the other we had the file system access. And on the file system access, you can use the move out of chroot again, because it's a working technique, because you only have to move directories. And I'm not going to tell you about the two other points because I have to hurry up. Linux containers are involved. If you have a privileged containers, if you have privileged container, then you can create nested containers in it, and you can use the mode out of chroot technique again. So I'm going to show you the demo about this in a hurry. So I go to the chroot, the Ubuntu box. Just a second. So we are here. If we list the containers that are running on this I guess the okay, what happened here? Okay, sorry. The demo guts are not with me. So here we are. If we list the containers, you can see there is LXC0, it's running. So I'm going to attach to it. In the host of the operating system, you can see the railroad directory. When I attach to the LXC0 container and I list the root, then you can see the LXC0 directory. And And there is one more container in the privileged container. So I just create a Hacktivity 2015 directory here in the root directory, and from the LXCO I can access the directory. But before I do that, I'm sorry, I'm a little bit hectic. So I just change the current working directory to that directory on the nested container. I go back to the privileged container, and I go to the var lib lxc and lxc1, because that's the name of the container, rootfs. And in the root directory, there is the Hacktivity directory, as you can see. And I move that directory to here, which is the root on the LXCO. And that way, if I do some lookup, then I can access from the LXC1 the real root file system. So that way, if you have a privileged container, which is not a usual thing in the Linux containers, you shouldn't do that, then it is possible to break out. And the last demo here, which is, I guess, the most important. So the scenario here, we have a virtual hosting company that hosts different web pages. All of the users have FTP accounts that can be edited on the website of the hosting company, and we can change the directory of our users. So we can just change somehow. As you can see, this is the backend of that web page. We have the chroot user, the password of it, it's chroot, by the way, with SHA-1, with hash. The UID is 1000, the GID is the same, and the directory is home FTP chroot. I'm going to open an FTP connection to that server. If I list the content of that, there is the chroot2 directory, which has nothing in it. I go back to the web page, go back to the backend. And change the directory to the home FTP chroot2. I changed it. It should be there, and it is. I open another session to the FTP server with the same user, same password. If I list anything, I don't see any. If I list the root, I don't see anything because we are enclosed into the chroot2 directory. So I'm going to create the Hacktivity directory, change to the Hacktivity directory, and there is nothing in there. If I list back enough to the root, I won't see anything, just the Hacktivity, because we are enclosed in that directory. But if I, in the first session, which is enclosed to another directory, I can list the chroot2. In that directory, I can list the Hacktivity directory as well. But if I rename that directory to for the win, which was a successful rename, and I issue the other command, then I can access the real root. Because we are outside of that directory. So that way you can break out, for example, a hosting company's FTP server, and you can even download the passvd file because it's readable for everybody. Oh, so it's root hello Hacktivity 2015. Okay, that was my last demo. This is the URL of my tool. It is called Chw00t again. You can download it. It's open source. It's on GitHub. In the future, I would like to do some more research on the topic. If you have access to exotic Unices, for example, AIX or HPUX, then please tell me if I can test those, and I will add more slides and things to my tool. And if you want to help me by giving me accounts or try out these techniques on your boxes, then just download it and tell me. Or if you want to fix up my code, then I'm okay with it. Just tell me again. So please, if you would like to, just do. And I would like to say thank you for my girlfriend and my family for their support, what I get from them. For Wolfie as Soral designer for mentoring me, and Spender and Chw00t for reviewing my slides previously. These are the references for those who will download my slides from the Hacktivity website or my website or the GitHub. And thank you very much. If you have any questions, now is the time. There is my web page, my GitHub page, and my Twitter. If you like my presentation, please just follow me.